Hello, and welcome to another episode of Mr. Boskin Does Some Math. Today we have Grade 8, Unit 8, Lesson 8. So, Lesson 8, Finding Unknown Side Lengths. Which one doesn't belong? 3 squared plus b squared equals 5 squared. 3 squared is 9, 5 squared is 25. 9 plus 16 is 25. B would be 4, that works. B squared equals 5 squared, subtract 3 squared. Well, that's the same as this one if we subtracted 3 squared from each side. 3 squared plus 5 squared equals b squared. Three squared is 9, 5 squared is 25. 25 plus 9 is 34. That doesn't work out the same, and 3 squared plus 4 squared is 5 squared, which is the same thing we got for this first one. So, which one doesn't belong? That one. Okay, next we have, which side is the hypotenuse? Label all of the hypotenuses with a C. Okay, finding the hypotenuse. The hypotenuse, we should remember, is the longest side of a right triangle, meaning it is always the side of the right triangle opposite the right angle. So for triangle A, this is our right angle, opposite is this side, this is our longest side, that will be side C. Triangle B, what's different about triangle B? This is not a right triangle. I don't see a right angle anywhere on here, so there is no hypotenuse. Triangle C, opposite the right angle, longest side. Triangle D, opposite the right angle, longest side. Triangle E, opposite the right angle, longest side. And triangle F. So the longest side can be in any orientation depending on the orientation of the triangle we're working with, but it is always the longest side, and it is always opposite the right angle. Hypotenuse. Okay, next, find the missing side lengths. Pythagorean theorem, we remember, is a squared plus b squared equals c squared. A and b, we have a is the square root of 10 squared plus b, which is the square root of 40 squared, equals c squared. Square root of 10 squared is 10. The square root of 40 squared is 40, is equal to c squared. 10 plus 40, 50, equals c squared. To isolate c, we have to get rid of the squared. So we do the inverse, which is square rooting it. Do it to one side, do it to the other. C is equal to the square root of 50. Question number 2, find B. So on this one, we know the hypotenuse, so this will be set up a little bit different. A squared is the square root, or A is the square root of 8, plus B squared, B is a variable, we don't know what it is yet, is equal to C squared, which is the square root of 26 squared. The square root of 8 squared is 8, plus B squared is equal to square root of 26 squared is 26. To isolate the b, first we have to get rid of this 8. So we subtract 8 from each side. B squared is equal to 26 subtract 8, which is equal to 18. To isolate the variable, to isolate the b, we have to take the square root of each side. B is equal to the square root of 18. A right triangle has sides of length 2.4 centimeters and 6.5 centimeters. What is the length of the hypotenuse? So let's label these A and B because we know we're looking for the hypotenuse. So 2.4 squared plus 6.5 squared is equal to c squared. So 2.4 squared is 5.76 plus 6.5 squared, which is 42.25. Is equal to c squared. So now we have to add 5.6 plus 42.25, which is equal to 48.01, is equal to c squared. In order to isolate the variable, we have to take the square root. We do it to one side, we do it to the other. So c is equal to the square root of 48.01. Okay, our next one. A right triangle has a side length of 1/4 and a hypotenuse of length 1/3. So this is going to be A and this is going to be C. So A squared, 1/4 squared plus B squared, B is the unknown side, has to be equal to 1/3 squared. 1/4 squared is 1/16 plus b squared is equal to 1/3 squared, which is 1/9. In order to get the b by itself, we have to subtract 1/16 from each side. So b squared is equal to 1/9 subtract 1/16. Since those have a least common denominator of 144, 16 subtract 9 is 7. It will be 7 over 144. Now, to isolate the b, we have to take the square root of each side. So b is equal to the square root of 7 over 144. Which would also be the square root of 7 over 12. Our next one, we have a right angle here. And we have a right angle here. This one looks like it's going to require some extra steps. We first need to find out this height. So using this triangle, we know that this A, B, C, label our sides. A is 5, 5 squared is 24, 25 plus b squared has to equal the square root of 34 squared, which is 34. Subtract 25 from each side. B squared is equal to 34 subtract 25, which is 9. Square root of each side. B is equal to 3. So this length has to be 3. Now we have another right triangle because this has to be a right angle as well. If we label this one A, keep that as B, this is our hypotenuse C. A is x squared plus b squared, 3 squared is 9, is equal to c squared. The square root of 18 squared is 18. X squared plus 9 equals 18. Subtract 9 from each side. X squared is equal to 18 subtract 9 is 9. Take the square root of each side. X is equal to 3. So the length of this unknown here is 3. Okay. Are you ready for more? The spiral in this figure is made by starting with a right triangle with both legs measuring 1 unit each. So this length is 1 and this length is 1. The second triangle is built with one leg measuring 1 unit. And the other leg is the hypotenuse of the first triangle. This says find the length of x. So the length of this, which is the hypotenuse of this triangle. So this can be a many stepped problem. So if this side is 1 and this side is 1, a squared plus b squared equals c squared. A is 1, b is 1, 1 squared is 1, 1 squared is 1, is equal to c squared. 1 plus 1 is 2, is equal to c squared. Take the square root of each side. The square root of 2 is equal to c. So this length here will be the square root of 2. I'll erase this part and we can do our next one. Our next triangle has an A of square root of 2 plus B, or A squared plus b squared, 1 squared is 1, is equal to c squared, our unknown side of this one. Square root of 2 squared is 2, plus 1 is equal to c squared. 2 plus 1 is 3, is equal to c squared. Take the square root, take the square root. The square root of 3 is equal to c. So this length is the square root of 3. How about our next one? Our next triangle we want to find the hypotenuse of has a and b of the square root of 3 and 1. The square root of 3 squared plus 1 squared is 1 is equal to c squared. Square root of 3 squared is 3 plus 1 is equal to c squared. 3 plus 1 is 4. Take the square root of each side. The square root of 4 is equal to c. So this length here is the square root of 4. I feel like you would all be mad at me if I kept this going all the way around and did the work for everyone. Hopefully you've picked up on the pattern by now. Square root of 2, square root of 3, square root of 4. What do you think the next one's going to be? Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15, and x is the square root of 16. Okay, that's it for this lesson. Our quick summary: there are many examples where the lengths of two legs of a right triangle are known and can be used to find the length of the hypotenuse with the Pythagorean theorem. The Pythagorean theorem can also be used if the length of the hypotenuse in one leg is known and we want to find the length of the other leg. Here's a right triangle where one leg has a length of 5 units. The hypotenuse has a length of 10 units. And the length of the other leg is represented by g. Start with a squared plus b squared equals c squared. Make substitutions and solve for the unknown value. Remember that c represents the hypotenuse, the side opposite the right angle. For this triangle, the hypotenuse is 10. A squared plus b squared equals c squared, which substitute them in. 5 squared plus g squared equals 10 squared. To isolate the g, we have to get this 5 squared on the other side. G squared is equal to 10 squared, subtract 5 squared. Square both of those numbers, we see that g squared is equal to 100 subtract 25, which means g squared is equal to 75, so the length g is the square root of 75. Use estimation strategies to know that the length of the other leg is between 8 and 9 units, since 75 is between 64 and 81. A calculator with a square root function gives you a square root of 75 is approximately equal to 8.66. Ideally, we do like our exact values, so the square root of 75 is okay here. This has been another episode of Mr. Boskin Does Some Math. Thank you very much for tuning in. See you next time.